Okay, hello. My name is Muhammad Ajapar, and this is the assignment 2 for embedded course embedded system. And this is my solution for the assignment of ascending order, sort into the ascending order. So this is my code. This is the S file, and also this is my main. So now I'm just going to run the code and explain a little bit of how my code is working. Excuse me. So I'm going to debug it right now, and then just gonna start with F11, and now we go to the assembly. So the first step I'm going to do is that I'm going to put the input data and also output data into R0 and R1 respectively, and then I'm just going to initialize a couple of like counter and index. So over here, I already opened up the two memory. This is location for input letter, and this is for output. So we're just going to observe the output memory because we need to ascend the memory and then put it into the output memory. We need to ascend the array, the number, and then put it into the output memory. So I'm gonna press F11, then F11 again. So now it's just a process of um, in the transfer section. In this transfer section right now, it's just a process of load the data from the input, starting from the first element, and store it into the output data, which is in R1, like for all elements. So we have load load data register and then store the data, and then we increase the increment, and then we increase the counter too, so that it's going to loop perfectly, and then it's going to loop into the transfer until 32, all of the 32 value element in the array is already been transferred. So I'm going to press F11 for now, a little bit, so we can see that the first element has already put to the output, and then the second is 0, if I'm not mistaken, and then the third is, yeah, the element. And I'm going to skip everything, the transfer loop, class 10. So we can see the address for output is already changed. Right now, it's the same with memory 1 and memory 2 because this is the input. Everything has been transferred into the output over here. Everything has been transferred to output. So now we're going to continue the next step, which is to compare. I'm going to compare the first element with all element in the output, and then it's going to take the smaller element and then swap position to the first. And then we're going to do that with every element. So technically, this step is to get the smallest element in the array into the first element. So again, we're gonna load the first element, and over here we're gonna load the first element too. R5 and load R5 and R6, which is both is the first element right now. So we're gonna compare. We're gonna compare. So right now it's going to skip because both number is the same. So if it's equal, then it's going to go to the next. It's going to skip the swap process over here. It's going to skip the swap process. It's going to go to next. So this one is going to increase the increment for R6 later, so that it's going to load the second element. And over here, just compare R7 with 428 to loop with all of the element that exists in the array. So we're gonna just start comparing over here. And we can see right now, 2 and 0 has already changed places. So that's the idea. So basically, if I skip everything and then finish for one loop, we will get F F F F F F F F F F F F0, which is supposed to be negative 16 into the first output. output data. So it's supposedly it's already like complete for the first element. So now for the outer loop, we're just going to increase the increment so that we're going to start with the second element. So when we start with, I'm going to change the initial, or if not initial, the R4 and R7, which is the index that is going to be used, into 4. So that now we're going to start with the second element. Now, if I press F11, we can see at the memory, yeah, 2 and 0 is already exchanged already. So it's going to go around loop for 32 times. Not 32, right now will be 31 times to find the next smallest element. Okay, so I'm just going to skip one more, F10, and then we're going to see it's going to take F1. So yeah, the code is working and it is sorting itself right now. So I'm just going to skip over here. So we can see this is final the finest version of ascending order. Over here I'm just the studio already skipped R4. So we can see over here R4 is 0 F0, which is the first element of output, which is supposedly this one is -16. And then I'm going to put R5, the last element of the output. If I press F11, so we can see R0 has 0 times F0. R5 has 0 times 0, 0, 0, F, which is the largest in the array. So yeah, and then it's going to jump back to the main. So yeah, thank you.